This lesson is an introduction to quadratics. Now, I want to remind you about exponents. So we said that exponents are only applied to the term or the variable that's directly in front of it. So if I had an equation like this, and I needed to substitute negative smiley face in it, what would I have? Okay, so we have y is equal to x squared minus x. We know that x equals negative smiley face. So when we substitute it in, I need to put negative smiley face inside the bracket. All of that is squared. And then I'm subtracting negative smiley face again. But now when I'm going to simplify, I have to deal with the exponent first. So 2 negatives will give me a positive smiley face squared. And now this one, I only have a negative 1 times negative smiley face. That gives us a positive smiley face. Let's look at our second example here. Second example, we have y is equal to negative y squared plus x. And we were told that x is equal to a negative heart. Now, when I substitute it into the equation, I have y is equal to negative bracket negative heart squared plus negative heart. Now, the reason I put all of these into brackets is because I know that the entire x is this term, negative heart or negative happy face. After I've substituted it in, now I can simplify by using order of operation. And in this case, order of operation says I must do the exponent first before I multiply it with the negative sign. So the next row, when I continue, I would have negative bracket heart squared because the 2 negatives became positive and I have heart squared. And when I simplify here, a plus and a minus, it becomes a negative. So negative heart. Let's simplify again. We have y is equal to negative heart squared minus heart. All of that is to set us up for creating a table of values with quadratic equations. Let's first use this equation and graph it. Y is equal to x squared. The values of x, negative 3, negative 2, all the way to positive 3. We're going to create a table of values and plot it onto our graph. So the first one, I have negative 3 exponent 2. Negative 3 exponent 2 would mean negative 3 times negative 3. So that gives me positive 9. Okay, just to write it out here, negative 3 squared is equal to negative 3 times negative 3, and that equals negative 9. So this is just showing all of the work in case you want to know where I got this from. Next one, negative 2. I'm inserting negative 2 into my equation. So negative 2 all squared. That's negative 2 times negative 2. That gives me a positive 4. Negative 1 all squared. -1 times -1, that's a +1. 0 squared, that's equal to 0. Next, 1 squared is equal to 1. Oops. 2 squared is equal to 4. And finally, 3 squared is equal to 9. Let's plot all of those points into my graph. So our x and our y, just to remind you, we start at 0, we go in the x direction, and then we go in the y direction. So we're going to go -3 in the x direction, and then we go up 9 units. We're going to put our first point there. -2, +4. -2, +4. -1, 1. 0, 0. And then we have 1, 1. 2, 4. And 3, 9. Okay, so all of these are points on this quadratic graph. I'm going to join these together with a curved line. So the reason this is a curved line is because this isn't a linear relation. As a quadratic relation, we're going to be seeing curves. We also put arrows at the end to show that this graph continues. The name of this shape is called a parabola. And one interesting thing about a parabola is that a parabola always has an axis of symmetry. So when I say axis of symmetry, I mean that as it crosses this line, this is like a mirror image. So you'll see that this point has a mirrored partner on this side. This point is mirrored here. This point is mirrored here. Our axis of symmetry is like our mirror, and the equation for this axis of symmetry, x is equal to 0. Let's do another one. We're going to look at the equation y is equal to -x squared. So just to remind you here, the exponent is only applied to the x. It's not applied to the negative, so we need to deal with the bracket first. We're going to substitute this in and put a bracket around it. So I have negative times -3 exponent 2. So I'm going to write here negative times -3 exponent 2. According to order of operation, I need to do my exponent first. So I have negative times -3 times -3. That simplifies to negative times +9. And when I expand that, we get -9. For the next one, negative times -2 squared. -2 squared is positive. A +4 times a negative, -4. Negative times -1 squared is equal to, this is our +1 and a -1, -1. Next, negative times 0 squared, that's 0. Next, negative times +1 squared. That's -1, negative times bracket 2 squared, that's -4, and finally negative times 3 squared is equal to -9. Let's plot these points on our graph. So -3 and -9. -3, -9, -2 and -4. -1 and -1, 0, 0, 1, -1, 2, -4, and finally 3, -9. We have all the dots for our curve. Let's put that into connect all the dots. We're going to label our graph. And we have y is equal to -x squared. Now, just a reminder, before we had a graph that opened up. This was the original graph that we were dealing with on the previous page. So we had y is equal to +x squared. You'll notice that the difference now is we have a parabola that was opening up, and this parabola opens down. The original parabola was reflected in the x-axis. And what indicates this reflection is the negative. So notice the two difference in the equations. We had a +x squared, and then we had a -x squared. The negative isn't applied, the exponent 2 isn't applied to this negative, but this will make it change by reflecting it in the x-axis. Okay, let's draw 2 more graphs. We're substituting in to the equation y is equal to x squared minus 5. So now I have -3 squared minus 5. You could do this in your calculator or you could do it in your head. 9, this is going to give you +9 minus 5. That's a 4. -2 squared minus 5. We now have 4 minus 5. That's a -1. -1 squared minus 5 equals -4. 0 squared minus 5 is equal to -5. 1 squared minus 5 is equal to -4. 2 squared minus 5, that's -1. And finally, we have 3 squared minus 5, and that's +4. Let's graph this onto our Cartesian plane. -3, +4. 2, -1. -1, -4. 0, -5. 1, -4. 2, -1, and finally 3, +4. Let's join the dots with a curve. And if you're doing this on paper, you'll probably be able to do a better job than I can on the computer here. And we're going to label our graph because this is good practice. This way our viewers and our readers know what we are graphing. This is y is equal to x squared minus 5. We've created a parabola, but the parabola has moved. We're going to graph another parabola. This time I have a negative in front, so let's remember to put the negative outside of our bracket. So I have +9 times negative, so -9 plus 3. That gives us -6. Next one, negative times -2 squared plus 3. This is +4. Apply the negative, -4 plus 3, -1. Negative times -1 squared plus 3. -1 plus 3 is +2. -0 squared plus 3, that's 3. -1 squared plus 3. Now notice there's no bracket here, but if there's no bracket, it still means that the 2 is only applied to the 1 because the negative is not directly in front of the negative. So now -1 plus 3, that's a +2. -2 squared plus 3 is equal to -1. And you're starting to notice there's a pattern here. Because the left side is a mirror image of the right side, once we get to the vertex, you'll notice that all the numbers start repeating itself. Okay, -3 squared plus 3, that's equal to -6. I'm going to plot this into my graph now. I'll use a different color here. We first have -3, -6. So -3, -6. Next, -2, -1. -1, +2. 0, +3. +1, 2. 2, -1. And finally 3, -6. We have the shape of a parabola. Let's join the dots. And we have y is equal to -x squared plus 3. Okay, one more graph for extra practice. Now we have a number also inside the bracket. So -4 plus 7. According to order of operation, I must do the bracket first before I apply the exponent. So -4 plus 7, that's +3. +3 squared is 9. -5 plus 7 all squared. I have +2. +2 squared is 4. -6 plus 7. So 1 squared is equal to 1. Negative 7 plus 7, that's 0. Square it, we have a 0. Negative 8 plus 7 all squared. Negative 1 squared is 1. And you start to see we're repeating the numbers again. We've hit the vertex, so I can simply fill in the rest with the mirror image. Okay, so we have negative 4, positive 9. Negative 4, positive 9. Negative 5, positive 4. Negative 6, 1. Oops, I'm going the wrong direction. Negative 5 and 4. Negative 6 and 1. Negative 7, 0. Negative 8 and 1. Negative 9 and 4. And then finally, negative 10 and 9. Join your dots for a parabola. That one didn't work out very well. Here's our parabola, and we have y is equal to x plus 7 all squared. Last one, we're going to substitute the values in here. 2 minus 5 squared. That becomes negative 3 inside the bracket. Negative 3 squared is positive 9. 3 minus 5, negative 2. Negative 2 squared, 4. 4 minus 5 all squared, that's equal to 1. 5 minus 5 squared is equal to 0. 6 minus 5 squared is 1. Once again, I'm starting to see that we're repeating itself, so I'm going to fill in the rest of those numbers, and we're going to plot this on the graph. I'll use red this time. 2, positive 9. 2, positive 9. 3, positive 4. 4, positive 1. 5 and 0. 6 and 1. 7 and 4. And finally, 8 and 9. Okay, let's join the dots with a curve. And we have a parabola here. I'm going to label this. Y is equal to x minus 5 all squared. And here we have it. We have